Welcome back, everybody. Say hi in the chat if you're joining us. So, it's been a while since we did a live stream. I'm all out of sorts today, but yeah, we'll go with it. So, just to recap what we're doing, we are building pick and place machine software. We've got pick and place machines like this one behind me, and they move around and put components on PCBs, right? And the moving it around and putting the components on the PCBs is one part of the problem that we're trying to solve. The other part of the problem that we're trying to solve is basically planning what to put on the PCB and where it all comes from, and all this kind of thing, and how you go from an EDA design to a list of parts and placements to put in the pick and place machine. Like, what do you put in it, and then once you put them in it, where do they all go? And then we also have to solve problems like panelization, because your EDA design normally only has coordinates for one of these things, but then you need to replicate it multiple times, and therefore you need to know how many of these do I need, what are all the coordinates for each of the individual units, and what is a unit, where does it start, what's the rotation of it, and all this kind of thing. So that's the bit that we're doing at the moment. So the last time, at the end of the last stream, which was so long ago I had to go and look it up, the end of the last stream, we managed to get the Gerber viewer integrated into the Planet application, and this is what the screenshot looked like of that. So on the bottom right hand side over here behind my face, we've got the Gerber viewer, and then above it we've got the definition of a panel. And on the left hand side we've got the list of placements. Okay, so that's where we got to last time. Between then and now, many small little things have changed. Many things have changed. So for a given Gerber file, which is one of the files that you get from your EDA tools when you export them for manufacturing, you have multiple different Gerber files, and each Gerber file has a purpose, and that purpose is supposed to be stored in the Gerber file itself in the form of a file attribute. Now, in order to display Gerber files, you need types that define the things that a Gerber file can contain. You need a parser to read the file, and then you need a viewer to be able to display it. Right? So we've got three things, and we've got three separate crates for those three things. Let me bring up the browsy. Right? So we've got Gerber types, which is in the MakerPnP repo now. It's not a fork. This is now the official source for it, and we've published a few versions of it recently, and we're up to 0.6 now, which is excellent, and it's very complete at the moment. So one of the things that we had to add was support for attributes, and we had to define all the attributes and so on. For instance, we now have a whole bunch of unit tests, like these. Yeah, where are we? Let me see if I can find one. Yeah, like aperture attributes. So you create an aperture attribute, and when you serialize it, it looks like this. Hopefully this isn't too small. Let me see if we can zoom in a bit. There we go. That's better. Okay, so you create an aperture attribute, for example, and when you serialize it, it looks like that. But we had to define each one of these as per the spec and so on, and then add support for it, right? So we can define it as a type, and we can serialize it, which is great. But we also need to be able to parse it. So we've got additional changes to the parser, which now support that. And it really was quite a lot of work adding all these different attributes. Where are they? Oh my god. Yeah, these ones, for example. Not those ones. Hold on. Let me find it. Yeah, these. So basically, for every single aperture attribute that you can possibly have and all its parameters, we now have tests for those. So this is a list of all of them. We've got support for those now. Yay! So we've got updated Gerber types, updated Gerber parser, and then we updated the Gerber viewer as well. So the Gerber viewer, yeah, let me show you that, where we're at to on this. Let me open it up again. Gerber viewer, new window, make it smaller. Close everything, show the readme, run it. Okay, so the Gerber viewer, it's got a little demo. Let's make this a bit bigger, which you can pan around and scroll. And this is where this is now, and it's pretty good, if I do say so myself. Other things that we also added is support for image transformations. So we've got those in there now as well. That happened. When I say image transformation, there's specific Gerber commands which allow you to flip the whole thing or rotate the whole thing or scale the whole thing and swap the axes around. So they're all in there now as well. So that got done. Yeah, so that's sort of the updated ecosystem for displaying Gerbers. Yeah, you can find all the source of that on the main repo. So, what else has happened? Many things. Yeah. Other things that happened, egui 0.32 got released. And this is all well and good. Well done all egui people for getting a release out. Yeah. But every time there's a new version of egui, it's a bit of a problem. When you're creating such a large application like the one I'm creating, because you've got many dependencies, and then the ecosystem itself needs to be sort of updated to support the latest version of egui. Otherwise, you're going to have a bad day and things won't compile. So you'll end up with two versions of it if you try and update your egui and then one of your dependencies is on the old one, then you end up with two versions and nothing works. So all the dependencies need to be upgraded to 0.32. Some of the people that own these crates did it, and they were on the ball, but most of them did not. So I created pull requests for egui-taffy, egui-data-table, egui-double slider. No, that one was done, but they forgot to do the release. Egui-mobius, and I think there was another one. Oh, there was the tree view. Yeah, the L tree view. So all the dependencies now support 0.32. Some of the pull requests have emerged. Some of them haven't emerged yet. But my forks of them have got the code that I need in order for them to compile, which is good. So when they finally release the updated versions, we can bump the dependencies and use the latest versions, which is all good. Also, if you remember a while back ago, we were dealing with egui layout pain and taffy and all this stuff, and having to do hacks to get a table to be resizable inside a docking window. And then we looked it up, and there was no support in egui for being able to constrain the resize to a particular axis. There is now. That got done. So this pull request shows how that works. So you can resize in both axes, only on the y-axis, or only on the x-axis. Right. So that got done. But in doing that, it turned out that I'd introduced a bug and then Windows couldn't resize themselves, and I hadn't realised it. So I've been looking at my UI file. I'm like, why can't I resize this window properly anymore? I mean, it used to work, and then I tried to work out where the problem was coming from. Was it in my sort of tab document example that we created like back last year, or maybe earlier this year? And that didn't have the problem. After I upgraded that to 0.32 of egui, so I'm like, oh, where's the problem going in? And then I realised I'm using my patched version of egui with this pull request and nothing else. I'm like, oh, what happens if we use that? And then sure enough, Windows couldn't be resized in that either. So then I had to dig into this a bit and see what on earth was going on. And it turns out that egui has this somewhat horrible sort of hack. I don't know, I call it a hack. Other people might disagree. But you've got the resize module, and the resize module you would think would be self-contained, right? But it's not. What happens is the window module loads the state for the resize, futzes around with that state, and then the resize code runs, and the state has been changed. And one of the bits in that state was the desired size. So you've basically got external code futzing around with the internal state, what I consider to be internal state of the resize. So we had to work that out and see what on earth was going on there. So now that pull request got updated, and now I can resize Windows properly, and I can use the resize constraint to a particular axis. Okay, so that got done. Yeah. What else got done? Oh yes, let's show you this. Well, you'll like this. Let's run it. Alright. So this is the app running, right? And we can have the project, and we can also see, and in the project we see the parts and the placements and so on. And we've got our UI, and this is the thing that was causing us the problem, and we can resize windows properly now. We can pull them out, and we can resize things, and we can resize. Oh, except that there's an egui bug, which I've reported as well. What was the bug? Yeah, so you just saw it there. Egui issues. This one. Bannock in a scroll area. Oh, great. So what happened was that I clicked the handle of the scroll area, this one over here, and it panicked. It shouldn't do really. Either that assert needs to be removed, or the assert shouldn't be created at all, but there's nothing wrong with the actual implementation as far as I can see, but you get a debug assert which causes your app to panic. So, yeah. Anyway, you just saw that in action. So basically it panics if the scroll area handle is fully visible, basically. So if you've got a scroll area and then you've got a handle for it and there's nothing to scroll and you click it, it crashes. And if you have something to scroll and click it, it doesn't crash. But the moment I make this bigger and then click it, it goes boom. Which is, you know, not ideal. So there was some investigation into that. Lots of faffing about. So, yeah, that's where we got to with that bit. What else has happened? Right, that's what we were trying to discuss. So, we've got our definition of a project, and we've also got our definition of a PCB. And a project uses a PCB. Okay, so let's bring this up over here. There's still some bugs to work out. So what you're looking at here is panelization preview, right? So within this, we can define the position of the units, right? And the rotation of each of these units, and how many of them there are. Right? We define the fiducials for it, and we've got all that. And this is good because we need that so that when you're trying to work out the coordinates for this unit, it's fine because that's what your EDA tool exported, pretty much. But when you want to work out how to place the same component on another one, you can't do that unless you know the origin of where that unit is, its rotation, and the rest of it. So you need to be able to define the panel for that in order to be able to place components on it. Now, the next problem is a little bit involved. Imagine you've got this panel and you put it in your pick and place machine, and I'm going to hold one of the corners. Let me use a different panel because that was not so easy to see on camera. Let's take this old one. Right, let me make this bigger too. Right, you've got a panel. This is the purple edition of the SP Racing F3 Evo, for those that remember that a few years ago. Yeah, purple. So, say you place components on this, right? And you want to place components on maybe this one and this one, but not these ones. Not these ones. For whatever reason. Maybe you're just assembling the first prototype panel and you don't want to waste all your components, right? So you say, I want to put components on this one. And you don't want to put them on the other ones. And it's a double-sided board. So you put components on the top and you need to put components on the bottom, right? But when you put it in your machine, you can put it in a bunch of different ways. So I can take this and put it in the machine like this, and then when I place the bottom, I can either go like this, and now I have to know where that unit is, or I could go like this, and I have to still know where that unit is, right? So what we've got is the need to define the assembly orientation. So in the drone world, you do your pitch is like this, and roll is like this, and yaw is like this. So 3D space. So we define assembly orientation as a pitch flip and then a rotation, and it matters which one you do in the order that you do it. And that means that when I put components on the top of this one, I pitch flip it, and now I know that it's this one over here which is further away from me compared to where it was originally, which is this one, which is closer to me. So going back to the UI, this one over here is unit 1, but when you flip it over, unit 1 is this one, right? So that's extremely important to know where the units are and the order of orientation for when you're assembling things. Now, it gets further complicated because each particular unit on the PCB can have its own rotation. And maybe your panel is fabricated like this, but you put it in your pick and place machine like this. And then maybe you want to flip it like this, or maybe you want to flip it like this to the other side. There's various reasons why you might want to, right? So we have to support all that. That was a faff, let me tell you. So in order to be able to display the panel preview for that, we need a way to invert the image. Now the image that you're looking at here isn't just me creating shapes on the screen using like GUI controls. No, that's not what we did. What we did was we actually created Gerber type a set of Gerber types and a bunch of commands, right? And then we gave those commands to the Gerber viewer and told the Gerber viewer to render the appropriate Gerber file to get the image, right? And the reason that we wanted to do that was so that we can export the panel preview as well. So in order to display the bottom of it, we needed to add support to the Gerber crates for the deprecated Gerber commands in order to do that. Let me see if I can find that. So in the Gerber specification, right, there is a list of deprecated commands. Yeah, these ones. Here we are. Right, and in this list there are axis select, image name, we don't care about that one, image polarity, I don't care about that one either, and then we've got the image rotation, and we've got mirroring images, and we've got offsetting, and we've got scaling. Don't really care about that one too much, but there's three in there that we need, which was the offset, the mirroring, and the rotation. So given that we now have support for those in the Gerber viewer, we're able to create the appropriate Gerber types commands to basically make this work. It's not entirely obvious until you sort of make one of them look a little bit different. There is a hint in that the fiducials change their position. But yeah, so what's happening there is that we've got y-axis mirroring going on, and then we've also got an offset, because if you mirror the y-axis, then all the coordinates will appear below this blue line here. So then we need to offset it by the size of the panel. So we need to know the size of the panel in order to do that properly as well. So we've got that. Then the next piece of the puzzle, there's quite a lot of pieces to this puzzle. The next piece of this puzzle is, how do you work out the coordinates for a placement that goes on here? So it's easy enough for the top. Basically, you just add the coordinate for where it's supposed to be, and then you add the unit. You offset it or transform it by the unit position. That's fine. Slightly complicated when you rotate one of the individual units, like this for the second one, for instance, right? But for the panel flipping, you also need to do another set of transforms when you do that. So now we have the ability to calculate the coordinates for each of the components on the units that we have. So if we go back to this and look at our placements list, right, and then if I sort it by reference designator, right, what we see over here is we've got a placement that goes on the first unit, a placement that goes on the second unit, third, fourth, fifth, and sixth units, and so on. And then what you'll see over here now is we've actually got the coordinates for where they're supposed to be, right? And these coordinates, hopefully, are correct. I spent quite a lot of time trying to make sure they are correct. And let me show you this. With the help of this. Is it going to focus? Come on. Not very well. You get the idea anyway. It's an example of where, a point on a unit and where those units are. And then if you flip it over, if I hold one here and flip it over, it's like that. And, bits of tracing paper so you can work out the translations and the orientation and all this stuff. So given this stuff, I was able to write some unit tests to make sure that all these numbers were correct. And there was a lot of setup in that code. Let me tell you that. Oh, good Lord. It was complicated. Let's have a quick look at it. So in planning, at least I think it's planning. Build unit. Hold on. I can't remember. There's so much code. I can't remember the names of all the methods anymore. Even if I've just been working on it, it's like, what did I call this thing again? Who knows? Oh, I suppose I can find it using refresh. Wait a second. Here we go. This one calls this one, which calls refresh placements. Here we go. Which calls build unit placement position. This one. Here we go. And then this is the test for that, which is a bit of a monster of a test because it needs so much setup code in order for it to work. So the setup code that it needs is like the entire panel size, all the offsets for each of the things, and then it needs a bunch of components, one on the top and one on the bottom, at known coordinates with the same coordinate top and bottom. And it needs to have offsets and rotations. Yeah, it was fun. So yeah, that happened. So we've got definition of the placements on each of the units. We've got the definition of what the panel looks like. We've got the gaps between it, the spacing, the coordinates, the center of them, the panel, the height of the panel, the width of the panel, various methods to compute all that. Nightmare. There was a lot of stuff in this one. And then eventually it runs the method and compares it against the assertions, and everything looks fine. Everything looks fine. All the numbers seem to make sense based on my tracing paper example. So that happened, but that broke some things. That broke quite a lot. One of the things that it broke, which took a little extra time to fix, was the CLI app. Now the reason it broke the CLI app was because the CLI app didn't have any way to define the panel. So in our GUI, we have this, nice UI to define the panel, which is great. We have the core methods to accept all this information, then store it in a file and so on. But the CLI didn't have any of that. And then one of the integration tests basically goes, create a project, create a PCB, add the PCB to the project, add the parts, set the phases, set the processes, and then generate all the artifacts. And the artifacts have the positions in it, right? And we've got this big long sequence of things that needed to happen, but there was a missing thing where we couldn't define the size of the panel using the CLI. So I had to add that. Right. But then, in doing that, we had to deal with clap. Okay, so in clap, right? Let me bring up the test first. Plan it out. Planner CLI. Here we go. Tests. Planner. Right. So configure panel sizing. This is the test that we needed to make work. So what we need to do is give clap design sizing for each of the designs that are in use on the panel. There may be more than one design size per panel, because a panel can have multiple designs attached to it, right? So unfortunately, clap doesn't have a good way of parsing a whole bunch of arguments into a vector. It's kind of madness that it doesn't really support it. What do I mean by that? So where you define the options in clap, right? You say I've got a subcommand and I want to configure panel sizing is a subcommand, and one of the arguments for that is supposed to be design sizing, and I want a vector of design sizing arguments, and the design sizing arguments are supposed to contain the design name, the origin, the offset, and the size. And the origin is a vector 2, which means it has two parts to it. It has the x part and the y part. So ideally, what you want to be able to define is the parsers for the individual parts for the design sizing args. Like, can I parse a design name with clap? Do I have a custom parser for design name? Yes. Okay, great. It finds it, it compiles. Do I have a parser for vector 2 in decimal? Yes, great, finds it, because there's an implementation when it comes to compile it, right? But if you want to have an array of design sizing arguments like we do, like this, clap has absolutely zero support for that. So what we want to have is that -- design sizing plus all its arguments repeated multiple times on the command line. So yeah, it doesn't have support for that. Which was somewhat annoying. So where is it? Clap. I did create a thing for this. Hold on, let me find the link. That was in May. No, more recent than that. Many things. Yes, this one. Here we go. Okay. So, for example, my case is slightly more complicated, but I created this issue so that people can discuss what we could possibly do about it. Imagine you've got a tool that works, I don't know, on a registry or just on a key value document or whatever, where the value has, it's like a key value. So you've got a key, you want to be able to give it the name of a key, and you want to give it the type of a value, the name of, the actual value, right? And you want to set multiple keys and values on the command line at the same time. And this doesn't feel like an unreasonable thing to want to do. And it's basically the same problem that I have with the design sizing arguments. Because basically your key and your value is your pair of arguments that you want to repeat multiple times on the command line, right? But there's no support for it. So, yeah. It took a while to document and explain all this and create the example, and yeah, so it doesn't have support for that. And then the ending result, what happens because there isn't support for it, is that you have to write your own parser for design sizing or for any other type of thing that you want to put in an array, which is kind of madness. And you have to basically write loads of string parsing code to like pull out all the individual parts for it, and it's just like that was another day of my life gone. Never mind. So that got done. Right. So after that got done, we were finally able to supply multiple design sizing groups of arguments on the command line and update the test, and then changes all the assertions for the X and Y coordinates for each of the individual placements and so on. So that all works now. So I'm happy that that's all working, which is good. What else got done? There's so much stuff has happened. Right. So back to the UI. Another thing that happened is that when you're setting up your configuration and you've got your list of Gerbers, right? Previously, we didn't have this purpose field. Now, if you remember earlier in the stream, I talked about the attributes and the support for attributes. The reason why that is important is because the information about what a Gerber file supports is supposed to be stored in the Gerber file, right? And the reason we need it is so that when you give the tool a bunch of Gerber files, it can look at the Gerber file and try and determine what the file function attribute is, and then map that to a list of things that we care about, right? So why do we need it? Well, if we want the placement view, right, to show us on the PCB where that XY coordinate is, right, this XY coordinates, like these ones, right, we need to know first what side it is on, bottom. Then we need to display the Gerber files that are for that side, and you have that information based on the attributes that are in the file. So what it means is that we can display the top of a PCB, the bottom of a PCB, and all the layers of the PCB in our tool now. Woohoo! So we've got the ability to do that now. So when you go to configure a PCB, you add the files, and it automatically works out from the file attributes, file function attributes, what the thing is for. Now, of course, helpfully, not all EDA tools export this information. So there is still more work to be done to allow the UI to ask the user what it actually is. Yeah. So for example, these files don't have the file function attributes in them, so it can't display the layers for the top, and it can't display the layers for the bottom because it doesn't know what they are. So if we go back to the list of files again, we see that we've got was that the one? Yeah, this one. I clicked on the wrong button. We see here that PCB side not available, purpose not available, because they didn't export the files with the right information in it. So we need to make this editable. And I added a refresh button so that if you get new files with it in, then you press refresh and then it appears, and you're good. So you've got the panel Gerbers here and the design Gerbers for each design here. And we've got lovely artifacts. Yeah. Egui. It is in debug mode. Whatever. So, yes. Right. So, getting back to what we're going to try and do next, is that now we've got all these things in place. Wait a minute. There's more things that I've got to tell you first. Hold on. I'm getting ahead of myself. So you might have noticed a minute ago, when we looked at this, we've got this little inset thing up here, which has a list of the files and what its purpose is. And it sits in what looks like a window, but it's not a window. So in egui, there's a concept of a window, right? What's a window in egui, you're asking? Okay, so egui doc uses windows. So if you pull out a docked thing, you get a window, right? This is a window. Let's pull out another one. This is a window, right? We've got windows. You click on this and it appears above that. You click on this and it appears above that. And there's Z ordering with the windows as well, right? But the problem is, if you want a window that belongs to a window, which I do, then you can't do it in egui. There's no support for adding your own layers that are related to a window. So you can't add a window at a specific Z order. You can't say, I want a window that only appears when this window is displayed. You can constrain a window to an area, which is what happens with egui doc. Well, this one doesn't. But you can constrain windows to an area of the UI. So you could float a window above the window, but then when you click one of these, it sort of appears and all the layers are wrong. It doesn't work, basically. So maybe at some point in the future, egui will have better support for arbitrary layers. At the moment, it's got background, it's got foreground, it's got modals, and it's got always on top or something like that. I don't know what happens if you have two windows that are always on top, because there's still Z ordering between them, right? But it doesn't have any way to let the user say, here's my window, and I want windows that belong to this window. There's no concept of a parent or anything like that for the windows. So in order to make this work, I had to make my own windows. So yeah, we've got windows. Let's bring up the crate for that. egui tool windows, new window. So we've got a crate, which is published on crates.io if you want to fiddle with it. Close all the tabs, close all the tabs. And it's got some demos inside it. It's got a simple demo, and that looks like this. Right? So we've got a window, an egui native window, and inside it we've got a frame, and you can move these windows and they're inside the frame. Right? They don't appear above the frame, they go inside this area. And they pretty much mostly work, but there's a couple of weird issues, because you've got rendering layers and you've also got interaction layers in egui. Yeah. So when you hover a mouse over something, it needs to know whether that layer is at the front in order to show you the right interactions for it, right? So what happens at the moment with this is if I put my mouse cursor over here, you can see that it's changing and allows me to interact with the window behind it. So there are some limitations with this at the moment, but if you want one, it's fine. If you want more than one, you might find there's issues with certain controls. I think the table and this thing is not using egui correctly, and it's supposed to be going rect contains pointer or something like this, which it doesn't if it's behind something else that's got a clip rect in front of it or something. I need to go poke the table code to see if I can add a workaround for it. But it mostly works. You know, and you can resize them and you can resize them and so on. You can't click drag or resize unless it's at the front due to aforementioned limitations with interaction ordering and display ordering. But you know, it's better than nothing. So that's a simple example. Here's an example of it where you've got windows inside windows. Okay, so this is a window and this is a window in a window, which is the main thing that I needed to achieve. Right? And we can see that these belong to this. And if you were to resize this window such that it's obscured, it pulls them in so that you can always see a bit of it. You know, so we did that. And that, you know, all seems to work good. And then we need the final example where you've got a dock with windows with tool windows, which looks like this crazy monstrosity, which is what I use in my actual app. So here we've got a window that's initially floated, a dock that's initially floated, and inside it it's got these things, and then these are tabs and so on, and you can futz around with these and move them around and so on, and everything's happy, and this is what we needed. So we've got that. That crate is available on crates.io. You search for egui tool windows, and there it is. So you can use that in your own project if you want to. Right. Now, before I created the tool windows, which ended up being my final solution, I also wanted another container which I thought might be useful, but it turned out not to be yet, but it might be in future. So initially when I laid out this UI, yeah, there's no way to put this back up here. Yeah, they need to fix that. Yeah, let me just close these for a sec, restart this. Initially when I was laying out this UI, I thought it might be good to have something like what the IDE has. So in the IDE that we were looking at here, over on the left hand side and the right hand side here, it's got this panel, right? And it's got this thing. And you can move these around and you can have multiple ones of these things. Somehow. Yeah. Yeah, I'm not sure if you can only have 2 in this, but the point is that I wanted to have some sort of vertical stack with like little drag things in the middle of it. Why no showy? It's because it wasn't on. Right. So I wanted to have this behaviour because I thought that might be quite good. It turned out not to be, and that the tool windows were a better idea because they took up less space. But in the meantime, we didn't know that until we created it. So the other thing that we created was egui vertical stack. And we're going to run this. And eventually it'll run. Yeah. Did I update this for egui-32? Yeah. And this got updated for egui-32 as well. Right. Here we go. So what we've got on the left hand side is a vertical stack. And yeah, it was complicated. Especially when you wanted to put extra things underneath it. Or not. So yeah, so you've got this scrollable thing, the windows clip to it, so you can see the behavior here is that you can scroll it right, and it doesn't get any bigger than the largest one, and they expand, and you can resize things, you can reorder things at runtime, and all that jazz. So I had this, so I've got this in my toolbox of things that I can use now. So we ended up not actually using it yet. But maybe, I haven't decided yet, maybe I'll transition this PCB Explorer thing to use the vertical stack. And then maybe we can move the things to the left and right and top and bottom like you can in the IDE. But that's UI bells and whistles. Because you sort of want to be able to make things into their own tab, or you want to put them in it. So it's like, I want a sort of like egui doc like extreme, where any of these little windows or whatever can be placed and docked and floated anywhere. Much like I had 20 years ago when I was writing an IRC client in Windows. But there we are. Yeah. Yeah, so, right, so that's all the new stuff that happened. What are we trying to do again? Oh, yeah. Okay, so the thing that we're really trying to do, and the reason that we've done all this work and all this kind of stuff, is so that when you're looking at the Gerber view for the top of a PCB, right, or when you're looking at the top of the panel, which would be here if it knew what top was, that when you click on one of the components, it zooms it in and puts the crosshairs on the center of the component. That's what we want to do. Now, we've always been able to do that for well, we've always had the coordinates to be able to do that for individual unit, but we didn't have that information in order to do it for a panel. So imagine I'm showing the panel, and when I click on this one, it goes to over here, and then maybe when I click on this one, it goes to, I don't know, this one. And we want that to happen automatically. We're going to have a go at it. Let's go. Right. So, yeah. How are we going to do it? It's a good question. Let's go look at some code. I haven't looked at a lot of this code for quite a while now, because I've been way busy doing all the other things that I just mentioned. Let's see if we can find out what to do. Let's close this. So, going back to the, not Gerber viewer, the planner app. No, not that one. This one, the GUI app. Here it is. Right, so somewhere we've got tables, we've got placements. Placements table. Right. The placements table is used in a couple of places. One, it's used here, placements, and it contains the coordinates. And it's also used for the individual phases. And this contains only the placements that are appropriate for that phase, but it's still got all the coordinates. And that table is used in both places, so what we need is some way of finding the PCB tab that's open, that corresponds to the PCB that the project uses, find the tab, I suppose, that's got the panel on it, and tell it to move to a particular coordinate, and then find the design that corresponds to the unit and find its tab and tell it also to go to the design coordinate. So we've got panel coordinates for this one and design coordinates for this one. Right. Right. So in this table, the placements table, yeah, we've got a viewer somewhere. Here it is. This is our viewer implementation. And one of the things that it does, it's got show cell view. And in here, it's got the X and Y. And this is where it gets the X and Y coordinates from. So it goes to the placement state, and then inside that there is a placement unit position, and the placement unit position is what's used for a panel. So you've got the X and Y coordinates as they are on the panel. Right, and then the placement positions are what is in the what the EDA tool gives you. And we store both of these things in the placement state. So we derive the unit placement positions from the project's PCB's panel sizing information and the placement position. Hopefully that makes sense. So we've got those positions. Right. But somehow we need something that we can click, or maybe it happens automatically. Let's just make it happen automatically, because I don't extra clicks, you know. Meh. So we can see here that we've got this yellow sort of outline when we select a row. So something somewhere must be keeping track of what the current row is. And we want to hook into that, I think. I don't know what options we've got. I don't know what the API is. Let's have a look. Yeah. So we've got this trait, which is given to us by egui-data-table. And we need to find something in here. Oh look, we've got on highlight cell. And we've got on highlight change, called when a row selected highlighted status changes. Okay. I don't think we've got that in here. No. Let's borrow that and see if it works. Let's just slap it in here for the moment. On highlight change. Yeah. So, is this right? R. Wait, what? Come on, brain. Expected placements. Why? Yeah, okay, that one. Right, there we go. So let's just see if we can use these. Let's see what happens. It's not got the index. I don't know whether you need the index or not, though. Yeah, probably don't need it. So if we click one of these, we've got this highlight change thing here now, which is good. That's what we wanted. So it gives you the row. Fine, we can probably use this. Let's get rid of that. So, when we highlight a row, wait a second. What happens if you do a multiple select? So we've got this one, and then we've got this. It doesn't really do multi-select like that. But it. Oh, wait a second. What's it giving us here when I select multiple things? Because this hasn't moved, but I'm getting a highlight change notification when I select another one. That's interesting, because I've got C19. Wait, what? So I've got C3. Oh, wait a second. just fiddling with it just to see what it does. Yeah, it seems to be about right. That's kind of weird though. Look, it's repeated. It doesn't work properly. Wait a second. So I've got C7 to C17, and then I click C2. It gives me C7. So if I do this, and then this, and it's given me C5 again, even though I selected C3, C19, and it gives me C19 again. Okay, it's a little bit funky, but let's ignore the fact that it's funky and just run with it. Maybe there's a bug there which needs to be reported. It wouldn't surprise me. Fine. So we've got the row, and it contains the all-important unit position and placement, and it's got the side as well, which is also important. Right. So that's one piece of the puzzle. Now, the next piece of the puzzle is how do you make the Gerber viewer focus on a particular point? Yeah. Now, a while back ago, when we were making the first Gerber viewer, right, we ended up with this tool, which is pretty neat. Right. Top. Yeah. Okay. We ended up with this tool. And one of the things that I added to this was this go to button. So if we say, like, I've got a coordinate here and we can see the coordinate for this in the status bar down here. It's a bit small, but it says 1.0342071. So it's about 1 by 1.72. 1 by 1.72, did I say? No, 172 perhaps. Oh, it's a negative number. On the y-axis. There. So we've got this ability to go to, given a set of coordinates. So we need that. We need to port that functionality into the planner app. Right. That's another piece of the puzzle. I suppose we should look and see how we did it, because I don't remember. It was ages ago. Let's find it. Gerber viewer. Main. Go to. Search for the label. And then we take the X and the Y from the coordinate input controls. And then we call a method called locate view, which does this view translation stuff. Right. Yeah. Okay, So we've got that. I'm thinking about where to go next. Because in order to test this, we need, I suppose it's not too bad. Shall we just hard code like some random known location into the panel view with a little button or something? Yeah, let's. Oh, I've got a good idea. Here we go then. What we're going to do. I'm running the wrong application. Is in one of these little tool windows that I told you about a bit ago. Right. In one of these tool windows, we're going to make another tool window, right? And inside that other tool window, we're going to have some controls, which is going to be X, Y, and locate, or go to. And then we're going to make that work. And then once we've got that working, then we'll try and add the link between the two things. Yeah, that sounds like a plan. Okay, let's do it. Yeah. All right then. So, Planet app has a Gerber viewer tab. Right. This is the code that creates a tool window. And you create tool windows by creating a new instance of a tool windows object, and then you give it the UI. Well, you create a new instance, then you call windows, and then you give it the UI, and then it has this closure, and then what happens is that you get given a builder, and then you call add window, a bunch of other methods, which gives you a tool window instance builder. And then when you call show on it, it records this closure in a list of closures associated with the tool windows instance. Right. So, to make a new tool window, first we add a semicolon, and then we do something like this. And we'll just go tools. Sure, why not? We'll give it a title. And we're supposed to give it a function which contains the content. Right, and then inside here you can just do any normal egui stuff because you've got a UI. This is just an outer scope for the thing, in case we need to do some of the binding stuff. Right. So now we can go UI dot. I suppose we can go back to the Gerber viewer main method and steal bits from this. Yeah, self coordinate input parser. We need some state to be able to record some numbers that the UI holds. Yeah. And then we need some controls for them. And we need to parse that, make sure it's an F64. Then we've got a control. And then if it was actually parsed, then we displayed a different background color, so you know you've got an error, which is fine. Yeah, don't need that in. Yeah, okay. And then after they've been displayed, we take the X and Y values from the inputs again, and then we've got those available to us so that when we click a button it goes to the right thing. So let's just borrow all this. I'm gonna borrow all that. Why not? It's my code. I wrote it. Do what I want with it. Alright. So we've got that. But we don't have this self coordinate input, and this, what is self in this context anyway? Self is a Gerber viewer tab UI, which makes sense, and this has got a Gerber viewer UI inside it, which contains some stuff. And then we've got the UI state containing a value, which means we can mutate it, which is good. And that is defined yeah, that's one of those, yeah. And then we've got view state, which is this stuff, which we don't want to really futz with. We want our own stuff. So probably we need to stick some stuff here for those X and Y coordinates. So this coordinate input is defined like this, so we'll just borrow the same thing. Right. And now that we've got that in a Gerber viewer UI, we can try and get those. Not that bit of code. I've got to find the right bit of code again. This bit of code. So we've got self.gerber dot wait, what? And that's not public. Wait, hold on. Oh, because that's that. No, we don't want that. The coordinate input doesn't belong to the Gerber viewer. My bad. It needs to belong to the Gerber viewer UE tab. Let's just put it here. Yeah. And then go back to where we were. So I suppose we can just have that. Everything's fine. But the problem is, here we've got self, which is not mutable. So what we're going to need to do is wrap it in a value. But do we? You see, in the Gerber viewer UE, we've got we're not using like crux, and we're not using sort of like the Elm pattern and so on. We're just doing like regular egui mutate everything whenever you feel like it kind of approach. But in here we're being a little bit more strict about things. So what we've got to do, instead of letting the text editor mutate this directly, is we're going to say take a copy of it, mutate the copy, and then if it's changed, send a message with the changed value. Then when the message handler processes, that's got mutable state, it updates the state, and then the next frame you see more stuff. So we do that. Okay. So we've got this. So we're going to copy this and we're going to make it mutable. Right. And everything's fine. Right. But now we need to know if it's changed. How do we do that again? Let's go self multi-line, and you get one of those. And then it calls UI add on the editor. Fine. So this is where we get it. And then we go, if it's changed, then futz around a bit. Then we need to send a message. Gerber, viewer, tab, UI. No, Gerber, viewer, tab, UI, command. And we need something else here. Let's say X. I don't really care about like just one of them changing. I kind of want to know. I just want one message for like X and Y. So. Okay, let's say let coordinates change and make this false, right? And then we're going to go if the X one changed, then do that. Right, everything's fine. So we've got to do the same thing down here for the Y coordinate. Thus. And we need some to-dos for these things. Otherwise we forget. And then we need to do this thing again. But for the Y editor. Right. Then I suppose we can go if coordinates changed, then do the self.component.send with the message. Of coordinates changed. And then should we have it only send it if there's an actual valid coordinate? Yeah. So we've got this enabled flag. Right, and the enabled flag is set if both the X and the Y is okay, which means we can unwrap both of them. Thus. And is this the one that doesn't have a result? Yes. Okay. So we've got that. So it sends a command and everything's fine. Now, this bit of code and this bit of code, we need to move into the button handling stuff. We'll deal with the handling of this in a minute. Let's deal with the presentation first. Right? So here, it's going to be something like this. But this is going to be go to clicked. I mean, I suppose we could send the X and the Y here instead of dealing with this coordinates change thing. That's probably better, isn't it, really? And you can't click it unless it's enabled, and therefore it's always safe to unwrap it. Yeah, let's do that. I think that's going to be better. So it turns out I don't need this coordinates change thing after all. I suppose we can just undo that then. Yeah, like that. So we've got go to clicked with coordinates now. And then the handler code will have some of this stuff basically. Let's do the move by as well. No. No. Maybe later. So we've got this go to clicked. We need to add a handler for that, which is going to be what I just deleted there. Go to clicked. So we've got this coordinates change, which we don't need anymore, but we've got go to clicked now. And we should have an error somewhere. Yeah. I suppose this can be default for the tuple. Fine. Okay. So this needs to be a toString, and then the error is in this handler here, and it wants us to add the remaining pattern. So go to clicked, we've got X and Y, I suppose. Hold on. Why is this complaining? That's a fair question. Borrowed data escapes outside of method. Yeah, probably need to do that, and we probably need to. We're going to have some borrow check errors on this, but we're going to come back to that. Right, here we've got the X and Y, so we don't need to do any of this unwrapping malarkey. Let's put that safety notice back, because that actually makes sense. right? And we need to call a locate method, which we don't have yet. The locate method needs to be on the Gerber viewer UI component. So we've got self, and we've got this Gerber viewer UI, and we need to send it a message, I think. Gerber viewer UI command, which is going to be locate view XY like it says, right? Seems reasonable. And then there's going to be what? No action. I think that's where that should go. Yeah. Probably where that should go. So now we've got this locate view thing, and now we're going to have an error for that. Alrighty. And there's going to be no action for that as well. Right. So now we can do whatever that locate view method was doing, which was this. And this was in this view state, right? So the Gerber viewer tab, no, Gerber viewer UI has this notion of some state. This. And this view state lives here, and this is where all of the methods for like futzing around with the actual layers and stuff happens. So basically we need to plop that method in here, probably, because self view translation and so on is all of this stuff. So it's all, yeah. But we need to fiddle around with it. We've got this UI state. View state contains translation and scale. Hold on a second. Do we have these somewhere? We've got this screen center. We've got these somewhere. Or do we? Maybe we don't have these yet. Let me see where these came from. I don't think we've got these in here yet. Oh no, we do. We do have them. So they're in the UI state like I thought. Okay, fine. But the UI state is probably in... Wait, what? Wait, where was this? Too much code. So when we draw a crosshair, we've got this UI state, and this is the one we want, and this belongs to the Gerber viewer UI. Which has got these, right? Wait, where do we want the code? I mean, I thought I wanted it there, but maybe I don't. Because it doesn't have access to it where it is here. Let me think about this. Let's just do that. And put it here instead. In Gerber viewer UI. Clear layers, add layers, so it belongs with these ones and not the other ones. Because then it's got access to self dot. Yeah, then it's got access to those, right? Yeah, okay, we can refactor this a little bit. We need to get this center state out of here. So let's go. Let's do that. And then we've got that, which we can use. Now, I don't really think that we should be mutating the state of the Gerber state from here. I think we should be calling a method on the Gerber state to locate the view, which will use itself plus these coordinates. So it should do the multiplication, but we should do the other bit. Let's have a go at that. So let's say self let Gerber state self.gerber state lock on wrap. Okay, and then we go Gerber state dot locate view, and we give it the x and y. Let's give it two things. Let's give it the I suppose we could have used a vector 2 instead of passing x and y around everywhere, couldn't we? Probably should have done. I'll go back and change that in a bit. But this is egui coordinate. You got pos2 and position2 and algebra stuff versus egui stuff. It's like, what do we want here? Let's create a vec2 here. So I suppose we go point and then center screen pos, perhaps. And then we take this bit. Go state. And then in here, we do a locate view function. And it takes a point and the center screen pos. And then we have that in here. But we don't need to lock anything at this point. We just go self.view whatever equals this. And I suppose what? Point.x and point.y. It's already been casted to the right thing, and maybe it works. But there's a compile error. Why? It's not mutable. And center screen pos is a pos2, not a vec2. This should probably be a pos2 as well. Which means this needs to be a pos2. That seems reasonable. Right, now we've got to deal with this. So we've only got one error, which is good. But this self thing, what does it do with self? Right, it goes self coordinate input, right? It's trying to get these coordinate inputs from self, but it can't, because this closure has a different lifetime. So we need to what? I suppose if we move this bit up here and this bit up next to it, right? And then instead of going self.coordinate_input.0, we can now go x coord and y coord, right? And then because these are cloney things, we don't actually need to hold on to that. So we can clone those here, which is fine. But I think we still have the problem because we're trying to send messages. Because we're still using, oh no. And we need to use these as well here. But we're still doing this self-component.send, right? So I think what we need to do is clone the sender and then go send. And that should do it. Woohoo! But send needs an expect on it. And we need to do that. Okay. So let's change the coordinates for this second window so they don't appear on top of each other. Shall we make this be the first one? Yeah. So this one starts at 2020. Default size of what? 200 by 50? I don't know. Something like that. 60 to make sure it fits the first time. And then if we say what? 80? No. 80. And then run it. Yeah. Let's see. Let's see. So we've got a UI. Are we looking for this? No. This one. Where's my other tool window? Slightly confused by that. Where is it? Ah, it's because it's got the wrong ID. I didn't change this, look. Tut, tut, tut. It deduplicates the things with the same ID. What is this then? This is tools. Actions. Tools. Tools is a bit. Let's call it actions. I mean, it's sort of a toolbar, isn't it? But let's go with actions for now. Oh look, we've got another one. That's good. Things aren't laid out correctly though, are they? Still, I don't know. Maybe it works. Like, let's say 0, 0. Oh, we didn't add that. I can't type into it, it just deletes it straight away on the next frame. Let's fix that. I am an idiot. So you know that code I added a bit ago to find out whether the coordinate was changed or not? I do need that. Let's put it back. Let's put it back. Okay, so let but coordinates changed. False. Changes? Changed. Wrong key. Dot changed. One of those. Right. So now we've got this coordinates change thing. And now we can go if enabled and coordinates changed, then do the thing. Fine. Okay. And now we can add the event handler for that, probably. And it's moved. I suppose we can go clone. Which is fine. And now we can add this here. And then we've got the X and we've got the Y. And arguably we don't need these here anymore. Maybe we'll come back to that. So we have to go exactly like the autocomplete says, which is update the coordinates with these. But we've already done the parsing. Should we be doing the parsing? UI stuff. Go on. So here we can store the F64s. So, but we actually want to be storing strings. Let me think about this. So this needs to be X coord. Yeah. Okay. So we've got that. And when we get these strings, we save them and everything's fine. Okay. So that should fix that, but the question is, should we be doing all the parsing stuff here? Like, and here, and here. It doesn't feel like we should. If you have to question it, it's probably wrong. But let's see if it works first. We can come back and clean it up later. Yeah, probably okay. Okay, so we've got a design. And now if we can, we should be able to... No, why can't we type in here still? What did I miss? What did I miss? Oh, it's because I'm an idiot. We don't care about this flag. We just want to blindly accept whatever the user types in, whether it's valid or not. Because how it was, there couldn't be a situation where they were both valid because you haven't been able to type into both of them yet. So now we can type into them. But the background of the second one is changing and it shouldn't. So what's happening here? This is probably because, yep, we've got that in the wrong place. That would help. Okay, how about now? Oh look, we can type. This is good. So it should locate it to this point here when I press this. Yes! Happy days. And if we say 10 by 10, it goes to there, which is the EDA offset, which is perfect. And then if we add what? I don't know. Something like that to it. Maybe. It goes to the middle. more or less. I don't know the dimensions of the board, but you know, you get the idea. Somewhere there. So we can go to a position on the board using a tool window. Yay! Using a new tool window. But it's no good. I mean, it is, but it's not. We need to be going UI.horizontal. We need to get all this and stick it in one of these and play the egui indentation game. Woohoo! And then run it again. I can't remember whether my tool windows supported like auto resizing to fit the content or not. I don't remember. Cool. That's a bit better. Neat. Like that. That's good, isn't it? Arguably, we could have just put a toolbar at the top of the UI instead of a little floating window. But, you know, maybe we'll come back and change that. I don't know. We'll think about it. So, we can go to coordinates. I've only ever gone to a coordinate where they're both the same, so I suppose we need to check that the y-axis is correct. So if we go -10 here, because I haven't got them transposed, we're okay. Amazing. Happy days. Boink. Fantastic. Alright, let's deal with some warnings, because there was a few. Apparently we don't need this. That's left over from a previous commit, so we'll fix that first. What is this file? Unit. This one. Yeah, I forgot to do a commit before I started something new. I hate it when I do that. I want all this. I want all that. What else do I want? Oh no. I want this. Schoolboy error. I don't want any of the stuff to do with the Gerber view tab. I've not changed that except in this live stream. Placements, highlight change, we don't want that yet. I want all those. I want that. Don't want those. Yeah, okay. Planner GUI. Move debug rect code. Add layout debugging feature. That. Right. So now we're just left with the things that we've been just been doing. Except this, of course, which is left over from other refactoring, which I haven't had the time to clean up yet. But okay, so what were they? These ones. Oh, I suppose. Yeah. Nuts. We'll do another fix debug rect. Wait, no. what have we got left? Let's just rebuild it a second. I think these are all related to this commit now. Yeah, we don't use that. It's fine. Placement table, Gerber viewer. Yeah. This one. That one is the fix. Right, there it is. Okay. So let's do a commit with these in it, but first, format. Oh no, I've got another one. Fine. Everything's fine. So this is planner GUI add. We're going to amend this commit. What is this? Go to button to Gerber viewers. And what it means is, after we've done all that, is that that little go to tool window should appear on all of the Gerber viewer windows, because they're all the same. So it should be on here, and it should also be on here, and it is, which is good. Who knows what that's going to do? I mean, it's not going to do anything really, because there's no Gerber files. Yeah, cool. Okay, so that's working. Now, what's next? So we've got to amend that commit, like I just said. And the reason we've got to amend it is we've got to do translations. But you know what? I'm just going to leave that for a little bit later. Maybe I'll just do that after the stream. I'm not interested in translations as part of the stream. So what we're going to do is now try and do the linky bit between the two things. So we've got our bit of code which gets triggered when a row changes, and we can get the coordinates out of it. But now we've got to do something this is going to be a bit tricky, this is. Okay, so what information do we have that we can send? Yeah, okay, so here we need to send a message that gets processed by something, which turns into an action, which then gets processed by something else, which bubbles up all the way to the top, because we're inside the middle of a placements tab inside a project. So the placements tab knows absolutely nothing about PCBs, and nor should it. Right? The thing that knows about the PCBs is the project tab, because it holds a project, and the project has a PCB. And the PCB has a file name. So we need to send a message up to the project, well, that gets handled by the project, which then creates another action which is handled by the main app itself, which knows about projects tabs and PCBs tabs, so that it can then find the right tab and then send it a message that says go to the right place. Okay. Okay. So if we go self, we've got access to a sender, which is good, I suppose. So we can go send. And this sender takes this type of command. I don't know why my IDE did that, but there we are. So we've got a row updated or a filter command, but we don't care about any of these things. What we care about is something else. Locate coordinate. Something like that. Right. Then we give it the coordinates. So here let's use algebra points. Let's create this as an object so we can name the things. Oh, wait, what? Oh, it's an array of highlighted things. Well, that's no good, is it? I hadn't noticed that this was a slice when I was looking at it earlier. I thought it was just bugged. Damn it. What do we do here? Hold on. I need to know what the behavior was. Because that yellow line didn't move, did it? When we were looking at the table. Okay. So we've got our placements. And we do this and we do this. And then the first time it gave us this, and then the second time it also gave us this. What? Why is it only giving us one? What? Hold on a minute. What if you do this? Why is it giving us an array? Is this because there's like, when we configured this thing, we've got this like notion of a row select or something? So the highlighted thing is C11, which is this one. But when I did this, C8 is at the top, and this is highlighted. The last thing I clicked was C8. But it gives us the first thing that was selected. And if I go from top to bottom, it gives us the last thing that was selected, and the thing at the top is the first thing that... I just want to know what this one is, where the yellow bit is. Okay, maybe there was something else in the API. On row updated, on row inserted. No. Why? On highlight cell. It's got a reference to a row. Let's try this. Because this one seems very broken. I'm just going to delete this because no. Let's see what happens now. Place your bets. Does it do what we think it's going to do? Is it going to give us the row that we last click, or keeps the first clicked one, or what? Okay, so we go C13. And nothing happens. Amazing. Breakpoint. That wasn't what I expected it to do. There's not even any code there. It's not going to stop on the breakpoint because it's compiled it out. What, does nothing even call it? What? What? Egui-data-table, come on. Did they remove it? Oh, fuck's sake. Excuse my French. So yeah, so it looks like they added an API, but then forgot to actually implement calling it. Okay, fine. So, like this on highlight change one, for instance, when we search for that, we see an invocation of it, right? But when we search for this, there's no invocation. Ah, dear, look. Click. No usage is found. Click. Shows your usage. Well now, I guess nobody else uses this functionality except me. Let's fix it. Come on. On highlighted cell. So when do we think it's even supposed to be called? I mean, is that even what we want? When a cell is selected. What's the difference between a selection and a highlighted? Should it be called like literally just before this? Or after this? It should probably be called after it, right? Is set selection the place to do it? Let's find the demo app. So this is where the row viewer is implemented for this. So let's borrow this and stick it in here, and this is going to be a row. Println row. let's just do that, right? Let's make sure we can run the demo with that in it. Okay, nothing happens. No printing. Right. So inside this date thing, we've got this visible selection, viz selection, get highlighted changes. See, what's a viz selection? Okay. Oh no. Oh no. What does this do? Ah. And then it creates an iterator from it, and then futzes around with it. But where's the set cell? I sort of want to. Yeah, it does feel like it's this. Yeah. So we've got visible selection pos. Linear index. I kind of need to know a bit more information about this. We've got this. Oh, we've got a cursor. Cursor state cell is this. Where's the? Okay, so we've got a visible column position. We've got a row index. That's kind of what we want, but. Oh dear. And it's setting it to a selection. Where's the column index? Because you can reorder the columns in these tables. Visible selection. This is the first row and this is the last row. It's a bit hard to know what this is supposed to be doing, really. Oh my god. row and column. We've got set interactive cell. Yeah, that's kind of what I want, but where should it be? Where should it be? CCI cell update, well, who knows what that does? No. Where to put this code? Oh, this gives you... Wait a second. This linear index is like a row and a column combined, I think. Okay, that makes a little bit more sense. So where we've got this set selection handler, somehow we need to get the row and column from this in order to find the row and to give it the column. How do you go from a viz selection to a row and column? There must be some other code somewhere that does it. Yeah, there's this thing, isn't there? Ah, there's a row col method on it. Look, that might work. What? Cell dot first. Is this? Hold on. Where was that? What was that one? What? Oh, because there can be multiple selections, and they might have spaces between the selections, and the selection has a first and a last in it. Oh, right. So what are we actually interested in the column? How do we get the column out of the selection? Is it always just the first one? I don't know. Row col. Why does it want number of, oh I see, it's got number of columns. So let's see. I'm guessing here quite a lot. Latest interactive cell used for keyboard navigation. Well, that's probably what we want. Let's see when that changes. Oh, all over the place. Great. So when's this called? Only there. Right. I think this is where we need to be doing it. Because this is doing this. Okay. Now that we have some understanding. And then that is what I think needs to go there. So there. And then somehow we need to get the row out of it. Visible row position. You see now. Visible selection to row, and it gives you an R back, which is the row. So it's this. So now we've got our row, maybe. Yeah, so we've got, but we don't care about this. What we care about is this. So now we've got the row, so now we can go self.viewer. Is it VWR? Yeah, no, it's VWR, isn't it? VWR, because this is the viewer here. On highlight cell, and we've got a row, maybe. Row index dot. Oh, it's like this, isn't it? And then we've got the column. Maybe. Probably dot zero as well. On highlight cell wants a row and a column U size. But is this the visible column or the actual column? What? This is a row index? Oh, how do I get the row then? Oh, no. I thought that was going to be the rows. How'd you get the row? Oh, it's like that. Let me borrow that. Right. I think we're getting there at the end, but what a faff. I feel a pull request coming on. So we go on highlight cell. So what happens now? And we need to test it with rearranging the columns as well, and also sorting. So I'm clicking this one, and it says cell highlighted row, belligerent minute 2552, which is what that is. Column 0. Column 1, column 2. Now let's reorder those, and then click this one, and it's column 1 and column 2. So this is the visible column. Now, is that what was actually intended by the API? Because the API doesn't say what there is the visible column. Oh dear. Like, what column is it? Should we probably change the API to give it both the current ordering and the index? Probably. Is that a breaking change? Yes. Was it already broken anyway? Yes. Was anybody using it? No, because the API was never even called. Does it force everybody to recompile everything and get compilation errors? Yes. And yes. But only if they overrode the method. And if they were overriding the method, that method wouldn't be doing anything anyway. and would likely result in unexpected behavior because you don't know what the column index was anyway. So, like, yeah. I'm just looking for other things that have got column in this. Like, set the value of a column in a row. Look, set cell value column. Right? So is this column a visible column or not? So set cell value in the demo, what does it do with the column? Let's have a look. So this is not the visible column. So in all likelihood, the API here is probably not the visible column index, which means we've got more work to do. Damn it. Yes. So, yes. So how do we get visible column pos? Visible column pos to the actual column pos. I want to see what other people do with these things. What other usages there are of this? Row col. Oh, I suppose we can find out by going because the other usage of the API, this viewer thing, right? Set cell value, where this column comes from, we can see how that's determined. So it's got column 0, and this comes from what? Column index. Doesn't really help. How do you get a column index from a visible column thing? Got visible column pos, but is there some mapping or something? Viz cols. Let's see where this is used. Not length. Alright. Basically, you iterate over the map and you look for the position of it, and then you've got that. Okay. I mean, we can do that, but Looking for other usages of this still. Yeah, look, and then they've got this same bit of repeated code everywhere, which is the same as that, right? Columns, iterate, find the position, get the index. Yeah, we're on the right track. So, yeah, let's see if we can find where we were doing the thing, which I've totally forgotten. Oh my gosh. What was the method called? Who can remember? I can't remember. On highlight cell, this was it. That. Here we go. So now we've got the index. And what does this do? Viz_cols gives us a vector of those back. And then we look for the position of ICC.0. What's wrong with this? What's this? Are we going backwards here? Expected a column index. Oh, no, we just. Oh, I see. Yeah, we are going backwards. It's the other way around. It's like this, isn't it? Maybe. We've got column index here now, and then this said it wanted a U size. I think it's that. So we click this, and we've got column 0, and we click this, we've got column 2, and then we move this over here, and then we click it again, and we've still got column 2, which is what we want. So we've got 0, 1, 2, and if you reorder it, it goes 0, 2, 1. Okay, fine. And now what we're going to do is bring sanity onto the API signatures, and we're going to call this index, like so. And then we're going to find the other one that used column index. We're going to rename that one too, because now it's clear. And like, we should probably do that for all of the other ones as well. But I don't want to go there. No. No. Probably should do that. But if I made that change, I would have to go back and check every single one of these methods that took a column as an input and just make. I'm not touching it. No. I shall mention it in the pull request, and then the author can fix it. I think that's the best plan of attack. Okay. So, I suppose we need to update a changelog. I don't know, maybe we need to do more stuff. Unreleased. What is this? Fixed. It was added to the API in what? 0.6.2. And I suppose that'll do as the commit message too. Probably. Let's review. So we've got changelog, we've got a println message on here. I mean, that seems reasonable to keep the println message in the demo, really, doesn't it? Oh, I suppose. Yeah. Because, you know, at least we know it's working now. And then we've got the code that makes it work. I suppose we can get rid of that. And then commit that. Let's do a little bit more testing with keyboard navigation. Alright, so we click, we move around. That all seems fine. What happens if we right click? Yes, we get one. What happens if we multi-select? Ooh, we haven't tried sorting yet. Hold on, we've got to do that. So it always gives you this one, which is fine because that's where the highlight is. It's light blue. That's good. Let's sort it. Go to the first one and make sure it gives us the right thing. A back achiever 31 whatever. Yes. So it works. Let's reverse sort it. Yes, it's still working. Click on a column. Yes. Yes, we're good. Yeah, that's definitely fixed. All right then. Time for a pull request. What is this? Egui-data-tables. Git log. Fix API 1. What branches have we got? It's master in this repo. Honestly, that change from main to master as the default branch thing is such a cluster. Because now on every single repository you're like, well, what's the main branch? What's the master branch? You don't know. You have to look every single repo. Whereas before it always used to be called master and it was fine. Anyway, let's pull. Let's have a log. Yeah, that's my pull request that they merged. Great. So let's check out that branch that we just had, which was fix API 1 and rebase it on origin master or just master. And then log it. Fine. I suppose we can go cargo test. What repo do I want to push it to? Yeah. Git remote. Let's push it to the MakerPnP one. Fix API 1. Here we go. So then we're going to go back to this, find egui-data-tables, go to the repo, and create a new pull request. Ah, but not there. There we go. Yeah. And that's the pull request. Of note, it wasn't clear whether the API wanted a column index or a column position, I suppose. It's still not clear in the API. Recommend renaming all instances of column usize to column index usize or column position usize so that it is 100% clear. Yeah. Yeah. All right, let's put a link to this. This PR was made during a live stream here. Thus. Yeah, okay, great. Pull request away. Let's put that in the list of pull requests. Created a BR to fix egui-data-table. Okay. So we've got that there. Then what? Then we need to add that to the branch that we're using so that now I can actually use this method in the project that we wanted to use it for. Okay, so we've got our MakerPnP branch. Which I could probably just reset the head of to be something else now. Yeah. Because this was that. And this has got those commits here, plus the merge, plus my new thing. So that's fine. Okay. And then we go git. I suppose we can just merge it FF only, can't we? Merge fix API FF only. Here we go. Because there's nothing else. And then we can go git push MakerPnP. Okay, and then we've got a commit number. And then this commit number we can finally put in our cargo file here, which has got this commit number here at the moment, and now it's got that one. Okay, so let's rebuild it. Wait, Not yet. On highlight cell. Right. So this was never called before. But now it'll be called. And then finally we'll be able to send a message. Just a quick recap for those joining the stream. What we're trying to do is link a list of placements and its coordinate to the Gerber and have the Gerber relocate to the coordinates position. So on the right hand side we've got our Gerber, and on the left hand side we've got a list of placements. And now when I click on a placement I get a debug message showing me the cell that I clicked on, and importantly the row that I clicked on, and it also gives the column, but I don't care about the column. But what I want is the cell, because this contains the PCB side and the 2 coordinates and then the other 2 coordinates. Right, and then now we can get that information and send it. Okay. So now we can go self.sender send, and then this sender wants one of these commands, and then it needs a new one, and then we were thinking about what to call it. Didn't we already do that? Wait a minute. No, we didn't do it. And this is going to be what? Locate. We're in the context of a project at this point. Locate. Gerber. I mean, Gerber's a bit specific, really, because there's other ways to represent PCBs. Locate component placement. Yeah, locate placement. That's what we want to do, isn't it? And we're going to give it names. So I suppose PCB side comes from, yeah, I don't need that. I suppose it might be useful to include other information in here, but let's just put what we want. Placement coordinate, and we'll create an algebra vector 2 probably of those things. God, the autocomplete is great these days, isn't it? These new LLMs and all this stuff, it's magic. And then we want unit coordinate. What's unit position? Is this already? Yeah. I mean, if we want to show an arrow showing rotation, then maybe including all this information is right. And maybe really we should probably group these things up into another structure. And maybe, I'm not doing this today though, and maybe this unit placement position should just be called a placement position, And then this should have a placement position as well. That probably makes sense. Probably do that later. Not right now though. For now, we'll just create another vector 2, and then I'll fix those at a later date. Look at the autocomplete, it's magic, look at that. Did I have to type anything? No. Was I going to type exactly that? Yes. Oh. Yeah. So that's what we want to do. We want to send this, and we've got all the information about where it's going to be. No, we don't. I mean, we do. But maybe we'll want more information, like the unit number. I don't think we do, though. Let's leave it out until we know we need it. Okay. So now there's going to be a compilation error. How long are we going for today? Look, well, a 3-hour stream today. Good Lord. Yeah. No. No. No, 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 no. I mean, it's correct, but also no. So there should be an unhandled thingamajiggery. Unhandled. Oh, that's found decimal. What is this? Oh, that's a decimal. What's this? This should be a decimal as well. Okay, so fine. So this should be a decimal. Fine. Okay, and now we've got the unhandled, non-exhaustive pattern thingy that I was trying to find. Right, good. So now we can add that. And then we'll add the missing fields. And then we need to return something. So at the moment we're in the context of placement. Now, placement is a table. And the table is used by tab. So much in the same way that when you fucked around with a filter, you return an action which is yeah, which gets the owner of the table to do something. Yeah. So I suppose we go sum, and then this wants to return self UI action, and self UI action is one of these. Hold on. Yeah. And then this is basically going to be locate placement again, right? I don't think it needs to clone anything. Let me have a look at that. Yeah, it's done it right this time. Good. So now we need to handle this action. Okay. So we compile and then we'll find probably 2 places where it's used. Yeah. There they are. So the phase tab has placements and the placements tab has placements. Let's deal with the placements tab first. This one. So when we get the locate placements thing, we need to do something. The placements tab doesn't know anything about PCBs, so we've got to send the message up again. So this needs to return a self UI action, and a self UI action is a placements tab UI action. So this is going to be some at some point we're going to get to a point where more information is added to the message that we return, which will be in the project. And then we're going to go PCB. Oh no. PCB side placement coordinate unit coordinate. There we go. Oh, side, not size. Where? Yeah, okay. Oh, and now. Okay. So, and then let's do the same thing in that other place that also had that. Which goes there, I guess. This is not placements tab though. This is going to be a phase tab UI action, which doesn't have that. Okay, and then we compile. We're going to get 2 more compilation failures. Okay, a bit more than 2. Because I've got some missing imports. Now we're going to have only 2. There we are. Right. So we've got 1 here and 1 here. Let's do the first one. And this is where I put it. Right, so now we're in the context of a project. So the method that we're dealing with now is update on the project, right? And the project knows about, project tab rather, knows, wait, is this a project tab? It is a project tab, right? This is the project itself, yes. Right. So, I suppose what we need to do is somehow get the project. And then we've got the path, we've got the planner call service, we've got the tabs. I don't remember what's in all these things anymore. It's been ages since I've looked at this code. we need a PCB from the project. Let me look at the definition of a project for a moment. Not that we have access to the project from the UI, we've only got access to the core service. So a project has multiple PCBs. It's true, it does. We did need more information. So, where are we looking at the placements? Where we create that first message here, the extra information that we need from here that we didn't put in this message was from the placements row rather, which contains the object path. The object path. And the object path contains the PCB instance and the unit number. And we need the PCB instance in order to index into the list of PCBs so that it can find the right PCB. So we need that. So let's forget that. Let mip equals what? Row placement state dot unit path. Yeah, we want that. Dot instance and unit. And we're always going to have it. So it's fine. So now we've got a PCB index. Nope. We've not got an index. We've got a PCB number and a unit number. One based. Right? One based, yeah. Yeah. So we've got the numbers now. Should we just send the unit path over, or should we send the entire refdes over and let it pull it out? I think it's probably more useful to just send the whole path over. I think we need that. Let's move these around a bit. Yeah. Okay. So let's add that same thing to all the other messages that we just created. Right. So if we look for the handler for this, which is this, now we've got a object path. Now we can put that in there, and then we can do the same thing. Thus. Okay. And then we find where this was handled. Not that one. And do the same thing here. It's a bit tedious, but you know, what are you going to do? And then we've got to find the last one of those, which is this one. And then we're going to go into here and add it to this one. And then finally, where we've got this one, we should have an error message. Yeah, that one. Right, so now we can get the unit number and so on off this. How do we get it? We've got our object path, and we need to get a PCB number. Yeah, what information did we retrieve about the project when we open the project tab? That's the question. Hold on a second. Yeah, we do need to know. We're trying to get the name of the file for the PCB that the placement relates to. That's what we're trying to do. And I don't know why my bookmarks tab has decided to appear over here. Don't forget to say hi in the stream if you're watching. Yeah. So yeah. So we tell the core service to load, and when it's loaded, we ask it for the Explorer and the overview, right? And then if we've got the Explorer, we get the project tree. And when we get the project tree, we get a project view of type project tree, which contains a project tree view, which contains a graph of tree view items. The graph of tree view items contains stuff, but it's not obvious what it contains here because that's defined in the planner app. Let's have a think about what adding a PCB does to the project. What file are we in here? This is this one, yeah. So when we pick a file, we add the project to it, and we get the project view and get the project tree again, you see? Yeah. Because what we don't have is a list of the PCBs anywhere. Let's have a look and see what we put in the project overview. We've got the name and the processes. We could add the list of PCBs to the project overview. That's what I'm thinking. We could create an entirely new view. Or we could take stuff out of the project tree, but I don't really feel like taking stuff out of the project tree is the right approach. Because you might not even want to display the tree, right? And therefore you don't request it. But the overview, that makes kind of more sense. Let's go with it. So, I mean, what are we going to add here? Like, we've got a PCB overview. I suppose we could have a PCBs view, I suppose. Let's have PCBs. I don't know. Yeah, but there's overhead in doing it. Every single view you have, you create extra overhead, and there's like other events, and no, I'm going to add it to the overview until it's a problem. Project overview. Because we're already requesting it, the information will be there straight away. When you add a PCB, it re-requests the overview, and it yeah. Yeah. And it's going to be a vector of what? Project PCB. I mean, I don't know whether this type has been re-exposed. It's a public structure. It's got a file, and it's got some unit assignments. We're only interested in this. And we're not even interested in this. What we're actually interested in is the resolved absolute path, or resolved path, I suppose, because this could be relative to the project. Aye. But it's okay, from the context of a project, we know what the project directory is, and therefore we can resolve it. Everything's fine. Let's do that. So it doesn't like it because partial EQ is not implemented for project PCB. I suppose we can add that. But why does it want it? I mean, it's fine. Don't need hash. Okay. So that's fine. Fine. So now we've got that information that we want. Well, I mean, we will have once we put it there. Let's put it there first then. Planet app. It's complaining that we've not filled in all the fields, probably somewhere. Here it is. Oh my god. PCBs. suppose we can just do this. Expected vec. Oh yeah, and then we've got to collect it. Yeah. And then okay. Apparently you can just call toVec on it. Fine. Alright, fine. Fine. So our overview contains that now, which is good. And the reason we wanted all that was so that when we were here, we can now index into it. If let some PCBs, no, overview. We've got a state somewhere. Where's the state? Project UI state dot lock unwrap. Yeah, overview UI. That's what we want, isn't it? Yeah. Wait a second. Do we not hold on to that? Like, I know that overview UI does, but if you close this, then you don't have it anymore. Yeah, no. Not sure. Yeah, because we get the when we get the view, this is what happened to it. We update some processes, and we look for the overview, and then if there is one, we update the overview. Do we want to hold a second copy of it, or do we want to ask the overview UI for it? I don't think we should ask the overview UI for it because it might not hold on to it. No, we need to do the same kind of thing as update processes does, which is self.whatever equals this. We want that kind of thing going on. Let's go self.update PCBs. And then make a method that does it like this. Which takes that and goes self.pcbs, project overview, and then we want to pcbs.map. Right, and we want to do something with it, but not that. I think what we want to do is just do this once, and that is take the file reference and resolve it to a path. So if we go pcb.pcbfile build path, and then we go self dot path. That should resolve it. And then we've got an actual PCB path which we can use to find the other tab. I suppose we can just get rid of that. And that way, this build path thing returns a path buff. So that means self.pcbs needs to be a vector of path buffs. And this comment is also the same. And then we collect that, and then yeah, semicolons. Okay, so we've got our update PCBs when we get that. Okay, good. So now, back down here, we cannot do this. We don't need to do this. We can just ask for the PCB directly from the ordered vector that we've got. So now we can get the PCB number and the unit number from the object path instance and unit, and we unwrap it because we always have one. It's fine. So now we've got those two things. So now we can go let PCB index unit index is these things -1 each, right? And then finally we can get PCB file from kind of curious to see what the AI decided I wanted to type. No, stop it, AI. Self.pcbs. And then we index into it using the PCB index. And we unwrap it because we're always going to have one. Unless there's this really weird situation where we don't. So if we go if let some, because things can happen out of order, and yeah, it shouldn't, but let's just be careful. PCB index. Now, PCB index is U16, which means you can't index an array via it, so you've got to go like that. Yeah, okay. Now we always have one here because this is we're not. I suppose we could do. I suppose we could do get here to be more safe. That's better. Right, so if we've got that, well, we need a map here probably because we've got a return. We've got a option here, and we either want to return a command or not. So I suppose we can just map this into the action. So we're supposed to be returning this is a very big switch statement. Oh my god. We're supposed to be returning self UI action. Self UI action is a project action. Yeah, and then this is going to be what? Locate component again. But now we can give it the PCB file instead of the object path. But we've got to clone it. And then we've got the other coordinates. Yeah, that should do it. Otherwise, we return none instead of an action, and that should be fine. Okay. Let's have a look. Let's import some things. Okay. So now we're at the application level, and the application can now look for the PCB tab and tell the PCB tab to do something. So we've gone sort of like back up the stack, and now we need to go down it somewhere else. Good lord. Crikey. Apparently we don't need any state either. We don't need unit index, but we're sending a message. So maybe we should have one compile error at this point. Yeah. Okay, we've got two. That's fine because PCBs can be default. Fine. Forgot that one. Alright. Delete that warning. Oh, and then we've got to do the same thing for when we handle placements, clicking into placements as well. So if we go back to where we just were, let's extract this to a method, and we'll call it locate component. Thus, and then we're going to do the same thing for the placements tab. So it'll have added this one, and we're going to do the same thing, but the only difference is going to be the name of this. Pop. And then it's going to do, oh, damn it. Up in there. I didn't press my modifier hard enough. And then we're going to move that beneath it. Go back to where we just were. Where's that one on this one? Is it at the top? It's at the top on that one. Let's see what's going on with this. Can't see the wood from the trees. There we go. Option project action. Yeah. Seems about right. Comma itself is mutable. Does it need to be mutable? Why does it need to be mutable? Yeah, and then so we've handled the placement table and the phase table. And now we've got this error, which is good, because we need to add support in the app itself for a high level message. And there aren't many of these messages because there's not many interactions between the different parts of the UI. There's lots of interactions in the project itself, but not between a project and a PCB, if that makes sense. So we've already got one that does something like this, which is called show PCB. And that basically looks for the PCB, and then if it's there, then it displays it. So our new thing is going to be very similar to that, which I suppose is good. But we're still in project tab. So we were in project land, and now we're in project tab land. So we just need to create an action for the tab, which contains the exact same things again. Project tab action, locate component with those things in it. Now we're going to compile again, and we're going to get another compiler somewhere else. Well, apart from the usual import statements. And this was the error that we were trying to get to. So now we're in the app itself. So like this is the app, and this is the UI command handler for all of the top level commands. So somewhere there was a show PCB one, and it's going to be something like this. Oh my god. It's never ending. It's very oniony, this one is. And it's basically going to be the same thing as this. Yes. Yes, this is nuts. Okay, so now like if you ever want to change the things that are in this locate component thing, you have to touch a lot of files. These are what we have touched so far. Oh my god. Right, anyway. Yeah. So we've got that. So now we should have another compile error somewhere else in another handler. Yeah. Now, finally, we're in the top level command handling stuff. Right. Right. This is where we are. We're going to go task none. Yeah. Now, on this, we've got a method called show PCB tab, which tries to find the tab corresponding to the path. And we want a bit of this, but we want more than that. We have to Oh, yeah, maybe we don't need that actually. We don't care about tabs, I don't think. If the tab's there, we use it. If not, doesn't matter. Let's think about this. So in app state, which is defined here, we've got a list of PCBs, and it's got a key and a PCB, and a PCB contains a path. Okay. So it seems like we should be able to go something like app state dot PCBs and then find the one with the same path, lock and unwrap. Okay, and then we go PCBs dot iter find. And that gives you a PCB key and a PCB. So candidate key, candidate PCB, I suppose. And what we're interested in is whether the candidate's PCB file is the same as the PCB file that we've got in the message. Yeah. And if it is, then that's the one we want. Okay. And then if we've got a PCB, then we can send it a message. PCB. What is this? Oh. Yeah. And then we can go PCB dot. No. Hold on. Okay. Key PCB. It's a tuple. I could map it, but I'm not going to. PCB dot, and then we've got a component, and we can send it messages. Send. So now we have a PCB UI command, and this is going to be locate component again. But this time, it's only going to have the PCB side and the placement coordinates. Now, I think we should probably include the object path here as well. I didn't, but I think we should. We're going to put that back in there. And we need to put in, oh no, we don't have the thing here either. Oh dear. we're going to put that in there. And then when we create that, oh no, another one needs it. Life is pain. This one needs it. This is madness. There's got to be an easy way to do all this stuff. Right. So this is where we create it in that method that we extracted, and this has an object path. So we can put the object path in this here. Right. Okay. Then we can go back to where we were, which was here. And now we can say create the variant, which will have all the things in it that we need. And now we're going to have another compilation failure, but hopefully only one. Oh, we've got 3. Oh, it's because it's the wrong decimal. How about now? Right. 2 arguments find. Oh, well, yes. That's because I forgot to put the brackets there. Candidate PCB is this. Why does it not think I've got this? Oh. Because I've got the wrong name here. Private. It is. I think they should probably have a method on to let outside things get it. Yeah. Oh, what? Yeah. Uh-huh. Hi. That is my girlfriend arriving home. Yeah. This probably needs to be a reference. Probably. Now, what's it complaining about here? Expected this. Ah. Wait, what? Yeah. Expected? What? This component, oh, I see, yes, because it needs the key. It's true, it does. So we need the PCB key here in order to send a message. There we go. Okay. Now that's the compile error I was trying to find earlier. Okay. Trying to get to. Right, so now we're in the PCB. So we've gone from the placements table to the placements tab to the project to the handler of the project to the app, back down to the, and then up again to the PCB, and now we're in the PCB handler code. Oh my god. Okay, fine. Now we've got all the information that we need in the right place. Okay. So. It's just crazy. It's crazy. It's crazy. So now what we've got to do, I think, is to find the Gerber viewers associated with the PCB side. Okay. Let's say none here first. And then what do we have on self? So on self we've got PCB tabs, which is good. We're going to lock and unwrap that. So we can find a tab and then send it a message. I think that's what we need to do. Let's see what find tab does. Tabs impl does this, and then here we've got find tab, right? And it gives you a tab key back if this returns true. Okay. What do we want here then? One second. All right, momentary pause. Tab key. I can't find a tab key. What are we trying to find? We're trying to find so the tab key, find tabs, candidate PCB tab kind. So the kind of tabs that we were interested in is the Gerber viewer tabs. Okay. However, there's more than one. If you open up the project, open up a PCB, you can click on the design, because there might be multiple designs on a PCB. You can click on the design and that will show you the top and all the bottom layers, right? And then in the tree view, underneath the design, you've got the words top and bottom. And if you double click top, it opens a tab with just the top layers on it. If you double click bottom, it shows you the tab with bottom on it, right? So hi. What we need to do is find the right tab for the right design. And we've got to reference the object path to find the unit number, and then look up the design from the the design mapping. Oh my god, it's just keeps getting more mad. Yeah, I need a break from all this. I think we're going to continue this like tomorrow or something. It's too much. We were going 4 hours now. It feels like a good time to break. I need a break. I need some water, etc., etc., etc. Okay, so I suppose to do find the right tab based on the object path and the PCB side. Oh, what happened there? To do send a message to the tab. There's more than one tab as well. Oh dear. Oh no. Oh no. 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 I'm not going to do it now. We need a vector of tabs. We've got to iterate through it. Oh my good lord. No. Oh dear. It's not just the first one. The API doesn't have oh no. It's all pear-shaped. Let's just comment this out for a second. Let's print out a message here just to see, you know, where we are, and then we're gonna finish this off. What can we do here? Self dot path. I suppose we can print that. Yeah. Let's add those in as well. And at least, you know, we'll print this out and hopefully everything will be totes fine. Why is it complaining about this last one? Argument is never used. What are you talking about? Oh, it's because something like that. Let's just see what happens when we click the placements. We should get a message if the tab is open. If it does that, I'm happy. If it doesn't, we'll fix it another day. Let's have a look. So we've got the PCB for the design that we're looking at, right? And we've got some tabs. And when we click on one of these things here, oh look, here it is, look. So that's good. This is epic. So we found the file, we found the corresponding tab for it, and that tab printed out a message. So where we're doing this debugging stuff, this println, is from the PCB tab itself, and where we're initially sending the message was from the placements table. It's just crazy. Oh dear. UIs. It's amazing that anybody ever builds UIs for anything ever, the amount of stuff that you have to do to make them work. But yeah. So in a minute, well, tomorrow maybe, when we click one of these, it's going to show, it's going to locate the coordinates to the right thing on the right tab, if you've got that tab open. So the idea is that, you know, you can click on top here and bottom here, and then you can set your UI up like this, let's get rid of these. Yeah, you can set your UI up and your zoom levels or whatever. Zoom levels another thing we've got to deal with. Oh dear. And the idea is that when you click one of these, either the top one shows you it or the bottom one shows you it, depending on whether the placement is for the top or the bottom. And then if you had this one open, it would just, you know, because this is showing you both, it would show you where it is as well. But that one's going to be more tricky because the component, yeah, it's going to be more tricky because it either has to use the unit coordinates or the placement coordinates, and then for the bottom it's going to be a nightmare on that one. Oh no, it might be alright. It might be alright because the placement coordinate is untranslated at that point. And so's the view. Oh man, it's going to be fun. Yeah, we're getting there. Honestly, we are. This is going to be great when it's done, though. Yeah, so join us on the next stream where we see if we can get this task completed, because this has been like one of my goals for like a number of months now, and it involved writing like Gerber viewers and everything in order to get this to work. So this has been like a few months in the making doing this, and I think we're only like about a day away from making it actually work now. It's been so much work to do it. It's just incredible. Right, so hope you enjoy this. If you did, give us a thumbs up at the bottom. Don't forget to subscribe, like, and you know, all the rest of that stuff. It does help out. And if you want to subscribe on Patreon, you can do that too. You know, that'd be lovely. So yeah, just remember, folks, it's only software. How hard can it be? We'll find out on the next one. See ya.